Welcome everyone to your exam week videos. All right. So much fewer video lectures today, just one small section. You can do the exam review worksheet as well. And then, yeah, you got to study for your exam. So here we go. Watch this. This is going to go by so fast. We're going to learn some rules for differentiation in this section. There are 3 rules that we're going to talk about. The first 2 we're going to talk about right here, and the second 2 will be in the next video. All right, only 2 videos. Super short, and watch this. This video could be 1.5 minutes long. Check this out. So we have some rules. Rule number 1 is called the constant multiple rule. So if I have the derivative of a constant, just some number, times a function, the constant can come out in front. Going to be k times the derivative of that function. We've already finished a third of the section. Already done a third of the entire section. How about that? All right, and then we can do another one. It's called the sum rule. That is, if you're taking the derivative of 2 functions added together, like this, all you have to do is take the derivative of the functions individually and add those derivatives together. Done. We finished our video. 2/3 of the section's done. When I said we finished our video, it was exactly 1 minute and 30 seconds into the video for me. Okay, so that's it, guys, for this video. The entire rest of the video is just doing problems, showing you different ways that these rules can manifest. So if you feel good right now, go ahead and get started on the homework. Otherwise, you can watch 1 or 2 examples. You can skip around, say you only want to see the harder examples and skip to the end of the video, all right? There's so many options that you don't have in a traditional classroom. Imagine you go to a traditional classroom and I'm talking about this and you're like, all right, I'm just going to fall asleep for 20 minutes. I guess you could do that too, but let's get cracking. Some examples. All right. Example 1, calculate the following. Part A. What is the derivative of 2x to the 5th? Also, we don't need this background, so we're going to get rid of it. All right, so this is just the constant multiple rule, right? What do we have here? We have a constant times something we know how to take the derivative. A constant times a function. So this right here, right, is our k. This right here is our f of x. So according to the property, this constant, this k, can come out in front, and then we just differentiate what's left over. This is going to be 2 times the derivative with respect to x of x to the 5th, and we already know how to do this, okay? We just use the power rule on this thing, and we're good to go. So this becomes 2 times the derivative of x to the 5th, bring the exponent down, right? This exponent comes out in front, and then we subtract 1 from the new exponent. 5 minus 1 is 4. So we have 2 times 5, like so, is 10. And then 5 minus 1 is, of course, 4. And this is our derivative. All right, and that's all there is to the constant multiple rule. Now, it can look a little bit different, but it's all the same stuff. So in part B, let's look at something a little different. The derivative with respect to x of x cubed divided by 4. So this doesn't look like multiplication. This looks like a fraction. This looks like division. But remember, you can always just rewrite it. If it ever makes you nervous, right? This is the same as 1/4 times x cubed. Because when you multiply 2 fractions, you multiply their numerators and you multiply their denominators. X cubed, remember, we can think of as x cubed divided by 1. So these really are the same things. And now again, right, this is our k. That's going to come out in front. This is our f of x. We'll differentiate that by itself. The 1/4 is going to come out in front. And then we'll take the derivative of x cubed. You really don't have to write this step. And probably after this example, I'm never going to write this step again. We have 1/4 times the derivative of x cubed. Exponent comes down. Subtract 1 from the exponent, we get 3x squared. And then just like before, right, if you want to, you can think about this as 3x squared divided by 1. Multiply those numerators, multiply those denominators, and you'll get 3x squared over 4. And that's our final answer here. That's, again, constant multiple rule. We have more examples. You want to skip to part E, that's when we're going to do the next rule. But we're going to do 2 more examples right here of the constant multiple rule. d dx of negative 3 over x. This one is very, very similar. All right, let's rewrite this as the multiplication of 2 things. Negative 3 times 1 over x, just like we did before. Right, just like we did before, it's negative 3 over 1. These are the same things, we just split them up. Well, the negative 3 comes out in front. That's a constant being multiplied. That's our k. And what are we left with? The derivative of 1 over x. Let's rewrite 1 over x as well as x to the negative first power. Remember, negative exponent means reciprocal. If I have x to the negative n, that's 1 over x to the positive n. And we really like writing things like this because this allows us to use the power rule. Now be very careful here when you use the power rule. The negative 1 comes down and you subtract 1 from the exponent. Negative 1 minus 1 is negative 2, okay? So this becomes negative 3 times negative 1. That's going to become a positive 3. And negative 1 minus 1, that's going to become a negative 2 like so. And this is a perfectly acceptable answer. If you wanted some more practice, you could rewrite this as 3 over x squared. Remember, the negative only applies to the x, so only the x goes in the denominator. Both of these are good answers. I'm only going to box 1 answer though. Because if you're answering a quiz question or a homework question and you box 5 different answers and they're different, I'm going to be a little grumpy with you, all right? If they're all correct, that's great. But if you box a bunch of answers and they're different, well then you're going to lose at least a little points, even if one of them is correct. It's like if someone asked you, what's the answer to question number 4? And you say, well, it's A, B, C, D. We got it. I know the answer is in there somewhere, right? So it's usually good practice to only box 1 answer. All right, part D. d dx, or the derivative with respect to x, of 5 times the square root of x. So again, right, we have our constant, we have our function right here. The constant is being multiplied, so it comes out in front. We're left with the derivative. That's not it. Nice try, Jason. The derivative of that function, square root of x. And this is just like before, right? Recall, very important to remember your algebra. Algebra is very important here. If I have the nth root of x to some power, the m is the numerator and the n is the denominator. So here, right, this is like the square root. It's like a 2 right there. And this is like a 1. We don't need to write that 1. But we can think about it like that. So the 5 stays out in front. And let's rewrite this. The exponent stays the numerator. And the index becomes the denominator. So we get x to the 1/2. And we can use the power rule on this, and we'll be good to go. So this is 5 times. Bring down that exponent. Subtract 1 from the exponent. 5 times 1/2. Remember, this is like 5 over 1. 5 times 1/2 is just 5 halves. We get 5 halves times x to the negative 1/2. And just like before, this is perfectly acceptable. But if you wanted some more practice, you could write this as 5 divided by 2 times the square root of x. And that's a good answer as well. So it's really good practice to be able to use both forms. Sometimes one form is more useful. Sometimes the other form is more useful. All right. If you're curious about when that is, feel free to ask me. Let's go on to the next rule. Okay. The sum rule. And the sum rule is kind of boring because, well, I think it's kind of boring. The sum rule is super exciting, all right? Don't listen to your instructor. Let's do part E. All right, d dx of x cubed plus 5x. Ooh, we're going to use a little constant multiple rule here as well. Right here, this first thing, this is just our f of x. The second thing is just our g of x. And our rule says that we can just take the derivative of each of these individually. All right, so this becomes d dx of the first thing plus d dx of the second thing. We'll use the power rule on the first guy to get 3x squared. The second one, you can use the constant multiple rule if you want. Take that constant multiple out in front. Or you could say this is a line. Y equals mx plus b. Our y-intercept is 0. The slope of a line is the m value. The slope of this line is just 5. And that's another way of doing this as well. Okay? Either way, this is our derivative. All right, let's do 2 more. And then we'll go on to the rule that causes a little bit more problems. Part F, find the derivative with respect to x of x to the 4th minus 3 over x squared. And again, it's just like before. This is going to be the derivative of the first thing. Plus, or minus if you want, the derivative of the second thing. Didn't we already find the derivative of 3 over x squared? Oh, we found the derivative of 3 over x today. So again, the first thing is going to be 4x cubed. The second thing, again, takes a little bit more time. Let's bring the 3 out in front. And let's rewrite the x squared as x to the negative 2th. X to the negative 2nd power, if you want to be grammatically correct, vocabularically correct. And then you can use the power rule on that second thing. So the negative 2 comes down. Negative 2 times negative 3 is positive 6. And then we subtract 1 from the exponent, and it becomes negative 3. And we have our beautiful derivative. I'm not even going to do part G. It's the same thing. Just you have the derivative of 2 things added together or subtracted together. Well, do them individually. Wow. Excellent. So this is the end of the video. But some people don't really watch the videos. They just look at the notes. So we're going to include something in the notes to confuse them. Okay. So we got a little happy math guy over here. And they're really going to wonder. They're really going to think they missed out by not seeing happy math guy up here. And happy math guy is going to be saying, with a little speech bubble, I love calculus. Whoa. And they're going to have to check out the video after this. Whoa, that's some quality right there. All right. Good luck. Get to work.